yesterday I made those knobs. They're right here. I was not on my game yesterday. Wasn't a tough day, so I just realized that I wasn't there. So I stopped machining and I worked on the shop and cleaned up. And some days it's just some days you're just not there, and it's just not working. And yesterday was one of those days. So I was going to do this part after I did the knob, but like I said, I just wasn't feeling it. Okay, so here we are. Here's this part, and actually this is pretty simple. We're down to our last remaining bits of our piece of bronze here. And that's kind of cool. You know, we saw this. It was, you know, we made parts out of it. What I'm going to do is I'm going to make, this is a input jack for like a stereo or, you know, something like that. What I'm going to do actually is I'm going to make this input jack screw into this. Usually these input jacks have a nut that screws on, and it screws onto like a plate or something. I'm going to make this screw into this, okay? So that's what we're doing. Now, before, let's look at the part really quick, and then we got to go over some stuff. We can see here that the threads are 3/8 that's what we're going to be talking about, so we'll go back to that. It's 1 inch in diameter. It's like it has a little flange here. And that the base of the flange is 7/8 or 875 thousandths. It's got a 30-degree bevel on the inside, so we'll do that on the lathe. And then we've got angled screws. They are very tricky to do. They're always tricky to do. What I did is I dimensioned this here. I'm going to try something that I've never done before, actually, and hopefully that might work. So when we do this on the vertical mill, it's going to be an experiment. I want to try something, all right? And I'll film it, and we can see if it works or if it doesn't. And if it doesn't work, we're going to have to solve some problems. I know how to do this with like a sign block or something like that. Don't worry about it. But I want to try something. Okay, so that's where we are. Okay, now, back to these threads, all right? This is 3/8 and I'll show you how I figured that out. And also, I want to show you that that's not on your typical drill tap chart. So if we were to go over to the drill and tap chart, we can see here 3/8, 16, 24. 32 is not there. So, all right. So what I want to go over is, first of all, how I found the threads. And what I have here is a gauge, a thread finding gauge. And so it says on here, I get my glasses to see. It says on here 20 to 50, so I know we're in that range. And when you pull this out, you can see it has all these gauges, all these different gauges, and they all have different thread pitches on them. Well, not thread pitches, but threads per inches on here. And so what I did is I looked at it and I said, okay, let's see, let's get close here. And I think I started at 28. I thought maybe it might be a 28, you know. And when you look to see if make sure you guys can see it. You look to see if it trying to get it on the white background. If the threads on the gauge engage with the threads on the part, and it's like, that doesn't look like it does. And so you move and you keep going. So there's a 30, and that was like, I was like, oh, that's really close. Maybe it's a 30. And I said, well, let's just try the next one, which happened to be 32. And whoa, boom, it locks. I mean, it's like perfect. It went in there, and I said, okay. So that's 32 threads per inch. And then with my calipers, I measured the diameter. I don't have them here. I'm not going to go get them. And it was 3/8. You don't use a scale. and it was just a few thousandths under 3/8. So I realized, I said, oh, 3/8 32. Okay, well, I was thinking that I might have to actually machine those threads on the lathe. But I looked up, now this is where I'm going, okay? So this is my machinery handbook for the shop. It's not mine, it's the school's. And it's kind of the hand-me-down. It's actually kind of important to me. Dan gave me this when he left. This one is from 1959. It says 1959, okay, right there. This is the small version that I was telling you about. This is the one that I use in the shop. Let's see what I even have bookmarked. I didn't even realize I had something bookmarked. Look what I have bookmarked. Keyways and splines. One page right there, okay? So this is a straight splines that are broached, and I was probably doing this for Baja, but I leave that marked so I don't have to find it all the time, so we can go over that. Now this one I brought in from home. This is the bigger version. It's much better, it's much easier to read. This is the 28th edition, and I want to just go over this. I bought this in 2008 when I graduated from Cal State LA. This was my graduation present to myself. And I have a smaller one, and that was the one I used. I had a used small one. But it says here, a reference book for the mechanical engineer, designer, manufacturing engineer, draftsman, toolmaker, and machinist. All right? This is it, okay? It was, I believe it was, if you look here, the original copyright was in 1914, but it goes all the way back to, this information, the earliest, wow, the Mechanical Engineering Handbook, 1879. So they've pulled stuff out from all the way back, 1881, 1879. The original copyright, like I already said, is 1914. Even reading the preface is really interesting, and it just talks about everything that the essential basics. It talks about math in here. I mean, if we go here, look, it talks about basic math and percentages. It talks about ratios, and then it goes into areas, volumes, geometry problems, gives you solutions for geometry problems. This is just in the beginning. And ellipses, I mean, it does it. It's all the trig is here. It's amazing, okay? And then we'll get into, it does, hang on. Well, wheels and pulleys, that's really important. And then it also will do loads. Let's see if I can just find that real fast. I'm not gonna spend a lot of time. So it'll find, a lot. Hang on, let me see if I can just get to it. There we go. Deflections of a beam. So it tells you when you fix a beam to like a wall or a building, and then you put weight on, how it's fixed. Is it supported on two ends? A single end are holes, etc., and double shear. God, I can't. I'm not thinking straight. And modulus of elasticity. Here we go. Solid beams, curved beams. Talks about all different types of alloys, of different steels, the hardening processes, heat treatment of steel. All right, you get it. Okay, I mean, it just goes tapers, the whole, you guys, everything is here. Here's milling cutters, their angles of their flutes, their shearing angles, all that. I mean, it's amazing. Look, dovetails. All right. This is twist drills, taps. Speeds and feeds. Broaching. Talked about that. It's kind of short, but you can see it real quick. Broaches. We did this one. Single keyway, right? We did that one. You can see all there's thousands of different. All the parts of that brooch. Remember I showed you that. So there's the angle of the tooth, the face angle, the depth of the tooth, the pitch from where it's cutting to where it's cutting. They have the radius in here. This is called the land, that back relief actually, or the clearance angle. This is it's all here, you guys. It's just so cool. Files. Let's see what it says. It's so cool. Remember I was telling you, bastard cut, blank, blunt, coarse cut, coarseness, curve cut, cut. A grade of file coarseness between coarse and second cut of American pattern files and rasps. All the different styles of mill files. Remember I was telling you I call them all mill files? There it is, all right? So those, remember I just showed you a few. I showed you like the round file, the triangle file, I think. I showed you the flat file, of course. All right, feeds and speeds of everything. Grinding wheel safety. Look at all the pages on grinding wheel safety. Wow. Lapping, drawing, so how to, okay, dimensioning, casting, lasers, torque, tension on bolts, wrench clearances. So like if you wanted to make a wrench, you make your own wrench. Every type of fastener, shoulder screws, socket, hexagon, socket head, shoulder screws, metric. All right, so where am I going? Let's get back on track. Here in the threading and the unified screw thread chart, I looked for 3/8. And what I found was 3/8 32. UN stands for unified. And then it said EF there with a 32. I went, whoa, that's extra fine. So it's a standard. It gives you the major diameter max and the minimum for that. And that's for a class 2A. I'm not going to get into that. That's how tight the threading gets. Pitch diameter, the whole thing. This is external, right? So this is external, and then it gives you the internal information. All right. And so what we got here is okay. So I'll cut to the chase. I was planning on doing the threads on my own, but I decided I had a box of taps, and it was a box. It's a box of taps that like they're kind of like mystery taps, and that we had laying around. And believe it or not, I found a 3/8 32 tap. And if I'm looking at it, it's not a taper tap. It's definitely not a bottoming tap. This is a plug tap. I can tell by the taper of it. So it's the in-between one, all right? But this is a 3/8 32 tap. I mean, that was just sheer luck, all right? But what I wanted to show you really quick was also in here is I needed to find, if I wanted to make my threads in this part, right? I needed to find, so real quick, I'm just gonna draw this. I needed to find the hole diameter before I put the threads in, right? So that's what I was after. And I said, oh, I'll just go look in the machinery handbook, okay? But while I was doing that, I found this. This is so cool. Pages. I found this formula. Oh, shoot. In here. CNC tapping. I mean, it just goes on and on. Hang on. Let me find my formula. Oh, man. Look at all this stuff on threads. Look at all the nomenclature on threading. Wow. clearly I was up to something here. I didn't even know that was there. Man, that's old. Okay, hang on. Let me, I know where to, so I'm gonna go to the index. So the index is really kind of important. And it's a little bit hard to get used to, okay? But you do. And when you sit down with it, you know, you need your hands need to be clean, and you need to read, okay? And look here, it says under taps, it says whole size before tapping. Oh, 1936. All right, so let's go to 1936. Page 1936. And for American Unified Thread Form, the whole size. Back to 3/8 32. This is a different chart. There's 3/8 32. We're in class 2B, okay? And look what it says. It says we want it to be the minimum 341 to 345. 0341 to 0345 is the size hole we want before we tap, right? Well, for the machinery handbook, the garbage truck's out front, sorry if it's loud, is just so useful, and I just wanted to show you that and share with you one of, you know, that's a very basic usage of the machinery handbook. Gears, bearings, ball and roller bearings, lubricating films, I haven't even read that. Key sets, more keyways, belts. You guys, everything is here, all right? So I would highly recommend that you get this, and there it is, okay? Machinery handbook. All right, back to the part. One of the cool things about this online learning is that I'm gonna do a lot of stuff that I normally wouldn't do in class. And there's lots, if you guys, like I've said it a few times already, but if you guys are watching these videos, like actually watching them, you're walking away with, I mean, a lot of tricks, all right? And I'm gonna do one right now. What I need to do here, this part is 0.375 in total thickness. What I'm gonna do is, I don't wanna just machine off and turn half of this into chips, okay? I'm going to save it because I am like that. And what I'm gonna do is I'm gonna mark half. This happens to be an inch, which is left over, what we have left over from machining all of our parts. I'm gonna mark off a half of an inch here. Okay, roughly, of course. And yeah, all right. So this won't fit in the bandsaw, the horizontal bandsaw. It's too small. Even if I were to like rig it up, it would tip over on me. Okay, it's just too small. I don't really want to hacksaw it because it's going to take a long time. Okay, so what I'm going to do is, this is one of the benefits of this class being this way. What I've got here is I've got a vise, and actually these two surfaces right here on this vise enable this vise to stand up. Okay, and now the vise jaws are perpendicular to the table. I'm actually going to put this in. You're like, yeah, you're right. I'm going to put this in this vise like this. Okay, lock it down. Watch this. Boom. Okay, remember, because before you can't cut something round, especially on the vertical bandsaw, especially something that you can't even hold. I mean, oh gosh, that would be a disaster. So I raised the guides up, and I also want you to notice, look at where my hands are. I mean, it's totally safe, right? Nowhere near. So even if this were to slip out of the vise or something like that, I'm pretty safe. Now, what I've got to worry about is when I start to get to the end. What's going to happen when I start to get to the end of the cut? Because what's going to happen is the kerf is going to start to close in on me from the pressure of the vise, okay? So that's what I need to worry about. Now really, really slow. Really slow. Okay, the bandsaw stopped. You can actually see it starting to close, and I stopped there. And now what I'm going to do, because it's awfully high, I am going to lower this to keep it more safe. And I'm going to finish this with the hacksaw. It's just warm. That's why. That's it. Okay. And use this one, make sure it's still, so it's about, I don't know, it's about a 16th, no, it's about a 32nd less than a half. And this one is the same. So I split that up pretty good. I'm going to save this for something else. I don't know what, but this is what we're going to use. So let's oh gosh, I forgot to tell you something. All right, so 341. Oh, I'm so sorry. 341 was our diameter for the tap. So what I did is I looked here and I said, where's 341? And there isn't a 341. But remember, I told you that when you drill a hole, it usually comes out a couple thousandths bigger. There's 339. And that's a letter R. So that's the drill for the tap we're going to use. 339. Okay? And I got that out already. It's right here. So let's go over. I'm going to bring this so I can trial fit it. So I got my print over there. I got my little input jack that I'm going to trial fit. Got my tap and my drill. Put that off to the side. And I've got the soft jaws in again. And this is what's so cool about soft jaws. See this? You can see this little ledge in here? It's like a bore that I machined into my soft jaws. So cool. Watch this. What I'm going to do is put it in there. Put the part in like this. Look at that. All right. And I'm going to use this tool. The plan of attack here is that I've got another part coming for a car. It's cool, actually, and so we're going to explore this concept a lot more when I make this part for a car. But what I really want is the hole to be straight on this side mostly. This side I don't really care about. I want the hole to be straight on this side. So this is where the jack's gonna go, right? The input jack, all right? That's where it's gonna screw into. So I do care that the hole is straight up to both sides, but I care more about it being straight along this plane, all right? So what I'm gonna do is I'm going to face this, all right? And then maybe I'll take it down to this diameter that I need here. And then before I take it out of the lathe, I wanna put the drill on the tap in. So it's flat against this face. I still want it to be flat this way too, but it's more important, okay? So we'll talk more about that when I make this car part coming up, once this project's done. All right, you might be confused about that. I think I explained it pretty clearly, but we'll get into depth about that shortly, all right? So that's our plan of attack, and then I'll take it out, flip it, and we'll put in the this angle with the compound rest. So I know you haven't seen that yet, so that's why I designed the part the way I did. By the way, I didn't really, this is not my idea. I ripped this off part online, okay? And I just made my own dimensions and stuff, but the concept is not my idea. All right. Leave that there. So first thing is we're gonna be facing. Okay. And see where am I at? 650, cutting with the tip. We're gonna just take very light pass. All I wanna do is remove the saw marks. Touch off. I'm just barely anything. I really want to get there. Okay. We're just gonna remove these saw marks. And I'm just doing this by hand right now. Okay. See what we're looking like here. So I still got some saw marks, all right? But while I was machining, I was thinking that, hey, maybe I can adjust my tool a little bit, and then I'll have my zero, and I can go in without even having to really even turn it off and do this, all right? So let's see here if I'm able to pull that off. So we need to go in 1/4 of an inch, all right? And you'll see what I'm doing in a minute here. So let's see what this says. Oof. So I might end up machining my jaws just a little, just a 5,000, which is another reason soft jaws are just so cool. All right. I think that's what I'm gonna do. So what I'm gonna do, all right, so check this out. Since I have a little bit left, I'm gonna adjust my tool angle. Okay, now what I'm looking at in my mind is I drew a line and I have a planes and lines, and I said, okay, I'm going to be able to face with the tip like this, and I'm going to be able to turn with the tip like this, maybe a little bit more like that. Yeah. All right. And I drew those lines and planes out here. But if I bring this down to the actual part, you can see, oh yeah. So I'm gonna be able to, okay, machine both faces, this face and turn, all without adjusting the tool, all right? And I'm going to end up machining slightly 5/1000ths of my soft jaws, and that's another reason why they are just so cool, all right? And I need to clean them up anyway, so we'll get rid of this. Let's make a mental note about what we've got to do. So we've got to go in 250 thousandths and make the diameter 0.875. Okay, here we go. Make sure we're not going to crash. and think ahead. Are we gonna crash if we go right? Are we gonna crash when we go? Nope, so we're good. Here we go. Really lightly, super lightly. I just wanna touch off here. Okay. That was even too much. And now I'm just gonna dive in just a hair right there, and I'm gonna power feed out. I'm only cutting a couple thou. All I'm doing is cleaning that up, making it look pretty. All right. Now check this out. First of all, stop the power feed, turn off the machine. All the saw marks are gone. I got a great finish. Do not touch anything. And now I can grab my depth indicator and I can zero it out, right? Because I came off that face and I didn't touch anything, okay? Now I'm in total control. I'm going to start turning, all right? And yeah, when I come out, I'm gonna take like 10 thousandths off my vise at the very end, okay? My vise, my jaws. All right, so touch off, okay? And I'm gonna take, I don't know, maybe 20 thousandths here, and I'm gonna do it by hand. And look at the gauge. At the same time, I'm going really slow. Real slow. All right, so what do we got? That's 200. What I'm gonna do, there's 240. I'm gonna stop there, all right? And I'm gonna measure. Okay, so that's at 50, right? That's at 50. And I'm a little bit over 1 right now, and I need to go 125 plus 20, so 100. I need to do 145 thousandths roughly, all right? So I'm gonna go ahead and do 100 thousandths down, okay? But, and then I'm gonna stop and measure again, okay? So I know what I need to do. I'm at 50, right? So where do I need to go? I need to go on the dial. Where do I go? I go to 150. So I'll just do 25. That might be too much. So I'll just go slow. Remember, this is a finishing tool. This is not for roughing, which I'm doing right now. I'm gonna stop at 240. Okay? And I'll take another, I don't know, another 25. Seems to be working okay. Not fantastic, but it's working. All right, now look down on my dial. Stop at the 40. There's another 25. Oh, so much better than yesterday. I was just not doing it, man. I was like not thinking stuff. Today I seem to be on my game. All right, yesterday was, whew, that was tough. Okay, so where are we at here? We're at 920, all right? So I need to go to 875, right? So 10, 20, 35. Let's do 30, and then we'll measure for the final run, okay? Let's do 30. So I don't want to do a whole 30, all right? I'm gonna do 5, 10, 15, I'm gonna do 20 and 10. And 10. 20 and 10. I'm gonna stop at that 40. Okay. We'll take one last measurement here. We are exactly what we thought. We have 5 thousandths left, and I'm gonna do 5 thousandths with the power feed. Check this out though, right? Here we go. 5 thousandths. Engage the power feed. Watch this. All right. So remember, 240, but I want to be 250. Now, this is the magic. I'm gonna dive in because I saved myself 10 real slowly to 50, and then I'm gonna back it out real slow. All in one shot. So there I am. I'm just barely touching my jaws. Remember I said I was gonna machine my jaws just a little bit? Okay, look at that, there we are. So yes, I machine my jaws, I don't know, 5 thousandths, that's fine. They need to be cleaned up anyway. That was great, okay? Now, good trick right there. I'm gonna turn the lathe on just so you can see something. This is way too close for me to get a file in there, all right? So, I'm daring, but I'm not stupid. Okay, so what I'm gonna do instead is, plus it'll look cool. Watch this. I'm gonna use my chamfering tool, okay? And just do this here. Just drop this in here. Remember, you got to have 2 screws. You got to have 3's best, but you've got to have 2. All right. So I'm just gonna. So now what I'm looking at is this is a pre-made carbide, cemented carbide tool. So I know that these, because it's pre-made, that these angles are true, like a real 45 to this face back here. So what I'm doing is I'm actually grabbing the line back here on the ways of the lathe, and I'm looking at that line and here, and I'm lining it up, all right? Now, that's not perfect, okay? That's not the way to line up a perfect 45-degree chamfer, but we're not interested in that right now. Remember, this is introductory class, okay? And plus, all I wanna do is get rid of this burr. My tool's low. My tool is too low, so I'm going to just raise it. This was that sticky. I gotta chase those threads. This stuff drives me crazy when it's sticky. Like, it drives me nuts. I don't know why, but it drives me, like, I don't know why it drives me so nuts, but it does. Okay, so that looks pretty good. Doesn't have to be perfect. And see, I'm really close down in here, so, right? Remember, I'm always paying attention to that. I'm always, and that is that because I am so diligent about paying attention in here. You guys, that's how I get away with making these small parts and getting in close with the lathe, all right? And not having problems. Because I've trained myself, I don't ever stop looking at what's going on in here. I don't ever, I'm just releasing the brake. I don't stop turning this chuck. You guys, I've just trained myself. These are these habits that I've made myself get into, and they are what enables me to do these small parts on the lathe and do them safely, not ruin the machines, not ever crash. Not that I'd never crash, but very, 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 very rarely do I crash, okay? I mentioned before that me and the lathe it's magic, all right? And part of the magic is just, I am laser focused on what is happening, and what's happening when this machine starts to turn and barrel itself down on my tool, okay? I don't know, I'll keep trying to explain it in different ways, but I'm looking at what's gonna happen, okay, when this metal comes barreling down onto this tip. What is going to happen, okay? So that's where my mind is at, okay? So we're good here. We can turn this on, and I'm just gonna touch that corner, all right? Just barely. Just wanna get rid of the burr and make it look pretty. There it is, right there. And that's it. There's barely even any chips on there. Okay, so that looks pretty good. All right. So now we are going to thread. Okay. I'm gonna get the tool out of the way. Okay. And I'm gonna put in my center drill. Okay, it's kind of far away. I'm good. All right. That's the problem with the DRO that I never use. I've actually considered taking it off. Maybe I could take it off and use it for something else or donate it to the makerspace. I just don't use it ever. Maybe I'm missing out on something, but I don't know. Okay, there's my... This is the scale for the digital readout. That's what I'm talking about. I just don't use it. I don't know what else to say. I just don't use it. All right. So there's my center drill. Here's the letter R drill. It's good, nice and sharp. All right, get this up close here. And got some oil. I need that for the threading, but just in case. I'm thinking about my speeds right now. I'm fine. I was wondering if I should lower them, but that's doing really good. I don't even think I need any oil. Okay, there's that. And I think, let me take the drill bit out. What I'm gonna do is, yeah, I want to. I'm gonna, just gonna drop this, this chamfering tool in here. And I just wanna, I'm gonna take the inside, I'm gonna chamfer the inside. Man, I'm on today, I love it. Okay. There, see that? That looks good. Okay. Now, so I would never, what I'm about to do, I would never show you in class. And a lot of machinists out there are gonna be like, oh my God, he didn't just do that. Well, watch this. I'm gonna power tap on the lathe. And the reason I can is, so I put the tap in, I'm gonna extend the ram out, and I'm gonna lock it, okay? The reason why I'm gonna be able to get away with this is because the hole is a through hole, all right? It's not a blind hole. This is gonna raise a lot of eyebrows, and people are gonna be like, nuh-uh, and you can't do that, and you can't do that for an introductory class. Guess what? I am. Okay, so what I got here going on is I put the lathe in 95. I'm gonna see about that. Yeah, that's good. And if I use the lever and I go down all the way, it makes the lathe go the spindle go the other direction. All right. All right. See. All right. You guys ready? Check this out. I'm gonna drop a little oil in there, and I'm gonna put a little oil on my tap. And because I'm talking, I want to make sure that I lock. I don't remember that I did. Yeah, I did. Anyway, all right. I'm going to bring this up close, make sure that I have enough clearance. I probably do, but I can also bring this over here and make sure that I don't crash. Yeah. Yeah, I'm good. All right, you ready? Watch this. I know. Boom. I'm giving a little bit of pressure. My hand is on the off and on lever. There, I can see it went through. Okay, reverse, and I'm pulling lightly. I'm not pulling a lot, just enough to help it. There we are. Okay. Gonna clean it, turn it off. Very first thing I am doing, as excited as I am to check my threads with my jack, I took the tap out. All right, and get this back and out of the way. So we'll grab my little jack, and I cleaned it out. Let's see if it threads. Come on, Blake. Yeah. Look at that. So that's 3/8 3/2 power tapping on the lathe. Look at that. That's cool. That's really cool. All right. That's cool. I'm getting excited. Yeah, I really am actually. Okay, and so let's finish this part. So cool. Okay. Put this in 650. When it's in low RPM, it's geared down, so it's really hard to move the chuck. All right, so here's our part. So far, I got a little bit of burr on there. That's okay. You know what? That's okay. All right. Let's see how this. Yeah, that's okay. Let's see how this runs. I'm gonna put it in here, and I don't know if you see, it's actually sticking. The flange part is sticking out about 25, 30 thousandths. Okay, and I didn't tighten it down real tight. Okay, I'm gonna get my finishing tool again, and the entire part is 3/8, right? 0.25 plus 0.1, it sure is, and that's 125. We already know we did this perfect to 250. So watch this. I have two choices. I can try and measure this flange, right? I don't like that. What I'm gonna do is I'm gonna measure the whole part. Boom, like that, all right? So I'm currently at 440 thousandths. I need to go down to 0.375. So that's what we know. Let's do it. I'm actually going to do the same thing I did last time I'm gonna face it, and then at the very end, I'll turn it, all right? Yeah, sure, why not? Actually, no, I'll move the tool. I'll move the tool. And I'm gonna face it from the inside out. The reason why is that if I go towards the middle, I'm going to end up deforming threads and have to chase it with the die, or I can come at it this way and remove material instead of deforming it and pushing it in. If I come at it this way, it has support, right? So it's going to actually cut the material as opposed to deforming the material, or the threads actually. All right, so here we go. Same as always, touch off, give it a little bump on the, nice and slow. All right, guessed it, I'm gonna zero out my depth indicator. $93, so that's 10, it's 18 thousandths. 75, 10, 18 thousandths. So we need to go to 58, all right? Ready? 58. Let's do 50. 50 by hand. And then come in here. Yeah, it's a tool doesn't like the angle, and I knew that, but that's okay. I know the tool doesn't like this angle; it likes more of a tip. And so I'll use the power feed. Just gonna leave everything where it is, and let's just check, make sure we're there. I think we are. A little over. I'm a little bit over. That's because it didn't like that angle. So it says, I'm just gonna keep it, 3 thousandths, it doesn't matter. What I'm gonna do now is just turn the diameter down to 1 inch. Let's measure. Yeah. 1 thou under. Good enough. Okay. And now, let me see. What am I? Yeah. So what am I doing now? All right. That's what I'm doing. I'm going to leave this here. I'm going to, what am I? Okay. So the next thing is, all right. The next thing is the chamfer for the, all right, this chamfer. It's 30 degrees, okay, off of 30 degrees, right? So, no problem. What we're gonna do is we're going to set the compound rest here to 30 degrees, okay? It might actually be, we're gonna check. It's hard to even see the scale on the compound rest, so you'll have to trust me, it's there. And then we're gonna machine this inside, okay? And we're just gonna machine it and bring it out just a little bit so we have a little bit of face left on there, okay? All right. So, gotta undo the, gotta undo the bolts here. And, come on. Down here is a scale. I know you can't see it. And I'm gonna move it to 30 degrees. There. So now it's at a 30-degree angle. And then I'm gonna tighten up these nuts again here. Okay. And okay, you don't need to crank on anything. And now what I'm gonna do is I'm gonna be using this to put in that angle. So I gotta adjust my tool to use the tip of the tool. And I'm gonna bring out this a little bit. That's all the way out. So I don't wanna be all the way out. I wanna be back a little bit, and I'm gonna move the cross slide over. That looks pretty good, all right? So you ready? Clutch off, bring this in. Now what I'm gonna be doing is I'm gonna put the carriage that way, and then I'm gonna come out with the compound rest. So see, my hand is on the carriage wheel, and my other hand is on the compound rest. Oh, rubbing on the bottom of the, whew. So what ended up happening there is I'm actually rubbing on the bottom of this tool down here, all right? So that might not work. Let me see if I have something. I'm thinking ahead. Yeah, that's not gonna work. So I'm rubbing. Let me show you. So I'm rubbing down here on the bottom of the tool as it's coming in. All right. I thought I had enough relief, but I don't. So I found this. This is gonna work. Okay. This is you can see there's much more relief back there. So this out of the way, and let's start again. Oh yeah. So, see, now I'm not rubbing anymore. It's nice and pretty. I'm gonna back off. I gotta get in there to see, and then I'll back off so you can see what I'm doing. Okay, so this is what I'm doing. So I'm moving, right? I'm just gonna move this over just a little bit, and now I'm gonna go in. Except I'd rather come out. All right, so I'm just gonna bump this, all right, just a little bit, and okay, we are taking shape. So I'm gonna go in. I'm just gonna bump this. About there. Alright, we're almost done. This might be it. So I'm gonna make sure this might be my last pass, my finished pass. So I'm gonna try and go slow and as steady as I can. Yeah. There it is. So there we are. Okay. What I'm gonna do is, where's that tap? Here's the tap. I'm gonna thread the tap in by hand, and the reason I'm doing that, I'm gonna do it from the back. I'm gonna do it when we pull it out. I'm gonna have to chase those threads there at the end. I got some burrs here that I would like to get rid of now. So you know how I'm gonna do that. Take this out and this here. I'm lining up that trick again. And I'm just gonna come over here and barely touch this. I don't want them there. There. Let's see. Yeah. So off camera, that's our part. I deburred this with fix this here. Fix this there. All right. I deburred this with the file, the triangle file with the ground corner, and what I did is I just ran the ground corner around this edge here like that, right? So I'd like to point out, for this particular project, this $2, $3 tool with ground corner has really, I mean, I've used it so much, and it really set the difference of the quality of the parts. You know, they really, it's made such a huge difference. This $2 or $3 tool, I mean, obviously the lathe and stuff, but the difference between the quality of the parts, the way that they look, and their finish, and the, you know, when you look at them and you say, wow, right? It's all because of this $2, $3 tool and a little trick, all right? So I just wanted to send that one home. I know I repeat myself often, but I do that on purpose because, man, this really set this project apart, okay? So before we move on, there's a little, I don't know if you can see it, but there's a little bit of thread stuck in here that I'm just gonna pop out with this. I'm gonna be real gentle. There it went. Okay, and what I'm gonna do is I'm gonna take our tap and I'm gonna, what's called chasing. And I'm just gonna, by hand, real gently, I'm gonna start this and I'm gonna run it through by hand. I hope I didn't cross thread it. Nope. I'm gonna see if it goes this way. Yeah, that feels pretty good. And I'm just by hand, I'm gonna do what's called chasing the threads. And because they are, that's tight. They are, they need to be chased from the machining, especially the front and the back where the part goes in. So just by really gently by hand, just gonna see that, okay? And now let's see if this fits. Ooh, that's nice. So that fits on there really well. See that? That looks great. Okay. All right, so we're moving on. We're almost done with this part. Okay. So at the beginning of this video, when I was explaining what we were going to do, I had mentioned that I was going to try this trick to drill these holes at an angle. And it was funny. While I was setting up the mill for the, to capture the video, I looked over to the side and I saw this block of metal. This is called a step block, and it's used to clamp material down to the table. Don't worry about that. We're not going to do that right now. But what I knew, and I saw it, I said, wow, you know what? That's 30 degrees. And right? And that's 30 degrees. We need 30 degrees. And I said, when I'm setting up the mill, I said, I wonder if that would work. So what I'm gonna do is I'm actually gonna cheat. Yeah, I'm gonna cheat. Okay, this is not a precision way of doing this, but neither was the way that I was gonna do it either. I was gonna come close. The right way, the machinist way of doing this is using maybe a sign block, which we're not even going to get into. It's a block of metal you do trigonometry and you get angles and all this stuff, okay? And there's different ways of finding the center and all this stuff. Okay, so I realize that's the traditional machinist way of doing it, but this is an introductory class, and I want to show you there's other ways to do stuff, and especially when things, so if this needed to bolt to a jet engine, we would need to do it the textbook way, all right? This does not need to bolt to a jet engine. So what we're gonna do is I'm gonna cheat, and what I did is we're gonna use this because now this is flat right here, okay? And what I did is I went over into SolidWorks where I drew this part up, and I measured off of the corner, all right, to this center line here, with a measuring tool in SolidWorks, and I found this distance of 0.196. And I said, well, look, I think this is gonna work, and it's gonna be fast, and yes, I'm cheating. I want you to know that. This is the screw that I want to use. It is a bit large for this part, and I realize that, but I'm doing it on purpose because I want it to look a certain way, okay? I know. So we're gonna go over to the mill right now, take our stuff with us, and I'm gonna leave this. What I need to do is I'm going to find the back of the vise. That way I can find the center of my part, okay? So I'm just gonna use the edge finder. I'm going to hang this off the side because I don't want to drill into the parallels, and I'm pushing down on everything. Okay, that's good. I'm just gonna lightly snug this up. Boom. I don't want it, right? Because I'll dent my part, okay? So now what I'm gonna do is I'm gonna find this edge. I don't like that. I'm gonna do it again. There it is. So I'm going to start with this, my number 2 center drill, and move over 0.196. Real slow. Really slow. Okay, let's watch the bottom. Drill bits coming out. Right there. Like 250 or 300. Some of you might be saying, well, now how are you going to do the other side? Did I get my, nope, didn't even get my parallels. And it looks like we even went pretty through. That's pretty cool. Huh. Let's see. I need to send that drill bit through. Yeah. All right. So, how am I going to do the other side? I'm going to eyeball it. Yeah, right there. Okay. Got it. Look at that. All right.